Well, good morning, everybody. And now the parts you've all been waiting for, the better parts. So we're going to start with this guy, Antoine de Saint-Exupéry, a famous aviator and writer, brilliant writer. He is best remembered for having written The Little Prince, which is one of those wonderful children's books that isn't really a children's book. Great bit of writing. But he wrote other books as well, and they were all brilliant. And in one of them in particular, he writes this sentence: "It seems that perfection is obtained not when there is nothing more to add, but when there is nothing more to subtract." Absolutely brilliant. I've seen this quote used over and over to describe engineering, architecture, design, anything which combines creativity and discipline. He was talking about the design of airplanes, but it seems to talk about all kinds of things. And I think it applies especially to software because of the requirement for programs to be perfect. We have a greater requirement for perfection than any other craft. And he gives us some wonderful insight as to how to attain that perfection. I think it also is applied well to programming languages. And the idea is that we can make programming languages more perfect by removing their imperfections. And that's what I call the principle of the good parts, which is, if a feature is sometimes useful and sometimes dangerous, and if there is a better option, then always use the better option. I think this is obviously true. A lot of people don't. They say, I don't want to use the better option, It's like, which really doesn't make sense, but there's a lot of that out there. And I think it comes from a fundamental misunderstanding. We are not paid to use every feature of the language. At the end of the project, there isn't a manager with a clipboard saying, did you use a with statement? Did you leave out any semicolons? Did you use commas as operators? No. We're paid to write programs that work well and are free of error. Free of error? Wait a minute, when did that become part of the deal? It has always been part of the deal. It's just we attain it so rarely, it's easy to forget that it's the first requirement. So the good parts, I wrote a book about it a few years ago, applied to JavaScript. And remarkably, it is still a bestseller in its category, which is extremely rare for software books. Software books often become obsolete before they're printed. And so to still be current years later is kind of amazing. And it's because what I identified as good parts actually are good parts. And so even though the language has gone through a couple of revisions since then, it is still relevant. Now, it's surprisingly controversial. There are a lot of arguments against the good parts, and I'd like to go through some of these quickly. The first argument is, well, that's just a matter of opinion. And it turns out it's not. If you look at programming from the perspective of what can we do in order to drive our error rate to zero? What kind of discipline do we have to bring to the craft in order to get zero errors? Then you have to go to the good parts, because taking unnecessary chances removes you from getting to perfection. I have the privilege of being the maintainer of JSLint, and I receive bug reports from people from all over the world, things like, we spent 2 weeks chasing down some obscure bug which was caused by someone mistyping a period as an equal sign. And that turned out to be syntactically equal, and nobody saw it looking at the code, and it just cost us a lot of time and money. Could JSLint find stuff like that? And the next edition of JSLint will. But there's a cost to that, and that is that there are certain silly expressions which you cannot use because they alias to these things which don't go wrong very often, but when they do go wrong, they really hurt you. So if you've always followed JSLint's advice, you will never experience those problems. That's not a matter of opinion, that is a fact. Every feature of the language is an essential tool. You can't take away the tools that I need to do my work. I'm not proposing taking anything away from you. I'm actually giving you a better way to use the language. By taking out the parts that are problematic, it is easier to write good programs, and ultimately that's what you want. I have a right to use every feature. Okay, the conversation has changed. We're no longer talking about what's the best way to write programs. We're now talking about my rights. And ultimately this argument degenerates into, I have a right to write crap. And I don't care. I mean, this is not an interesting argument. What's more important is you have a responsibility to write stuff which is good. And that's more important. I need the freedom to express myself. I want people to look at my code and go, what? I need to reduce my keystrokes. This is a really common one because we imagine that we spend most of our time typing. And if we could just figure out a way to leave out some of the keystrokes, that'll improve our productivity. Turns out typing is not where we spend most of our time. We spend most of our time gazing into the abyss saying, my God, what have I done? If you can reduce that time, you're going to be more efficient. If I could propose a way that I could increase the number of keystrokes by a factor of 10 and cut your errors in half, that would be a huge win. Unfortunately, I can't give you that advice, but that shows the proportionality here. And it's an insult to suggest that I would ever make a mistake with a dangerous feature. And again, we're way off topic now. And there's a good reason those features were added to the language, and this is absolutely false. So let me tell you a story. So Brendan Eich, the brilliant guy who invented JavaScript, put in a double equal operator, which did type coercion before it does the comparison, which means it sometimes will give you a false positive answer, which is bad because false positives are confusing and can cause bugs. And he recognized that he made a mistake. Now, he wasn't the only one to make that mistake. PHP has that error in it. Lots of other languages did it. But he was smart enough to figure out that it wasn't right. So when the language began its standardization, he went to the standards committee and said, now's the time to fix it. In fact, I've already made the fix in Netscape, and the fix made the code smaller and made the language run a little faster. So this is a really good thing to do. And the committee said, no, we're not going to fix it. We're going to keep it wrong because of legacy issues. And they offered instead a compromise. We'll put in the correct operator and we'll call it triple equal. Yeah. And we're stuck with that. So I recommend always use triple equal. Double equal was not put into the language for a good reason. So Brendan talks about foot guns. A foot gun is a feature of a language that you use to shoot yourself in the foot. So you go like, and he regrets that he put so many foot guns into JavaScript, and he admonishes the committee that maintains a language from time to time, let's not put in too many more. Because there are people who go, oh, all right, I almost always miss, it's great, watch, boom, missed. There's the fantasy of infallibility. You see this a lot, especially in younger programmers, that my skills are so awesome, I can just do crazy stuff and it'll work enough and it's great. And then there's the futility of faultlessness. You find this especially among old guys. It's never worked. It's never going to work. Why do we even try? It just doesn't. So two very, very different attitudes, indicating two very different life experiences, but they both end in the same place. That is danger-driven development. So one of the things that makes the scheduling of software so difficult, or the management of software so difficult, is the difficulty of scheduling. So when we're scheduling, we have to estimate how much time is it going to take to write the code. And that's really hard. We don't know how to do that. We guess, and sometimes our guesses are off by not too much, and sometimes they're off by a whole lot. But then there's an additional time you have to be concerned with, the time it takes to make the code work right. This should be 0, right? Because you should write it and it should work. But often time B is bigger than time A. Sometimes time B is infinite. And that happens when the code is finished, but the project is canceled before it's made to work. And that happens way too often. So if you're doing anything in A to try to save time, which adds more time to B, you're doing it wrong. Okay, we want to make B as small as possible. Sometimes when people are in a hurry, they think, well, we'll just write sloppy stuff because it's quick, because we just have to go on. Except they forget you still have to make it work. And it's much easier to make it work. You can make it work much faster if you write it well. You should always take the time to code well, even when you're in a hurry, especially when you're in a hurry. So we've got a new edition of the language coming out, the 6th edition, and it's going to have some good stuff in it. There's some new good parts being added to the language. I'm really happy about this. I'd like to share some of them with you. The first one, the best one, is proper tail calls. This is something we learned to do with Scheme back at MIT in the 70s, and finally this idea is getting into JavaScript. With this feature, JavaScript finally becomes a real functional programming language. And it's really simple. All that happens is if the last thing a function does is return the result of calling another function, or itself, it works with recursion too, then the compiler, instead of generating a call return sequence, will generate a jump. And a jump is a little bit faster than a subroutine call, so that's good. But more important, it can reuse the activation record so it doesn't have to allocate memory every time it calls a function, which enables whole new kinds of programming, like continuation passing style, which is an incredibly powerful form which we could not use until now. So this will be my most favorite new feature of the language. The next one is the ellipsis operator, which gives us a much better way of dealing with functions with a variable number of arguments. In the past, we had to use the arguments array, which was really awful, an awful, awful thing. So here you see two versions of the curry function. The first one is written in the ES6 style. The second one is written in the ES3 style. That's just appallingly awful. It's just ridiculously bad. There's lots of stuff going on in that function that has nothing to do with curry. It's just noise because of misdesign in arguments. Whereas in the new one, you just say ... any place you want to indicate, and lots of things could happen there. Just brilliant. I love this. This is my second most favorite feature. It doesn't allow us to do anything that we couldn't do before, but it allows for some things to happen in a much better way. We're going to have modules in the language, which are great. Historically, the biggest problem in JavaScript was the global object. JavaScript doesn't have any kind of linker, and so that common namespace is where everything collides, but that turns out to be a huge problem for reliability and for security. So we're getting modules now. The new module system is much better than the crappy require stuff that we have in CommonJS. This is really good. It's inherently asynchronous. It's great. So that'll be good. We've got a new let statement, which works just like the old var statement, except that it will respect block scope. So JavaScript in the past never had block scope. It only had function scope, which isn't bad because you can write good programs with function scope. The problem was there are a lot of people coming to JavaScript from Java, and the syntax of the languages are very, very similar. And so they assume that scoping works the same way, and it doesn't. And so they write stuff which is wrong because they're confused about how the language actually works, and confusion leads to bugs. And so with the new let statement, they will not be confused anymore, and I'm all for eliminating confusion from the world. We've got destructuring, which is another feature which is not going to allow us to do anything that we couldn't do before, but it provides a convenience, it reduces the number of keystrokes for doing certain kinds of things, which is completely unimportant. What's more important is that it can improve readability for certain patterns and certain idioms, and that's a worthwhile thing. I'll show you an example of this a little bit later. Then we've got weak maps. Weak maps, I think, are the worst named feature in the history of programming languages. It's an even worse, a worse name than proper tail calls. It's the way objects should always worked. In JavaScript, an object is a container of key value pairs, and JavaScript requires that all of the keys be strings. And it turns out that was a mistake. It should have been a key could be any value. That would be much more powerful. We tried to fix it but we couldn't because there are crappy programs out on the web which assume the bad behavior. And so objects are always going to be broken. So instead, we're adding a second kind of object, which unfortunately is called weak map. So, and that's a problem because nobody wants to put anything weak in their program, right? Come on. Yeah. But it's really good. And this is a powerful fundamental thing. It allows us to write programs that we cannot write efficiently in the current language. So that's a good thing. There are lots of other features being added to the language, a huge number of features being added to the language. Not all of them are going to be good. Some of them haven't proven themselves yet. Things like generators, I'm thinking probably are not worth the trouble. There's lots of stuff coming in. There's one thing which I am certain is a bad part, a very terribly bad part, and that is the new class syntax. This was the most requested new feature in the language. And the requests mostly came from frustrated Java developers who are now having to write in JavaScript because that's where the jobs are, and they're hating it, and they don't want to have to learn how to do this stuff correctly, so can you please give us classes? And they're not really getting classes. They're getting syntactic sugar on top of the prototypal system, so it looks like classes, but it works kind of differently, and so there's confusion, and you know where that goes. But worse than that, it turns out the best way to use this language is to think about functions. Functional programming is so powerful and so wonderful and so expressive, and if you're stuck in this class thing, you will never figure it out. You're always going to be stuck in this class thing, which turns out is really hard. It's unnecessarily hard and difficult and error-prone, and the people who are going to be using class will go to their graves never knowing how miserable they were. Here's a new feature that kind of straddles the fence. It's got some goodness and some badness. It's a new way of writing functions with the fat arrow operator. Unfortunately, it looks a lot like an equality operator, so I expect we'll see some confusion there. If you get a little dyslexic, it's going to go bad in unexpected ways. And the whole point is to eliminate the function word. There were people who complained, function is too hard to type. Well, there's this new thing now called keyboard macros. It's too much to read. Oh, okay. So we got this thing. So here we've got an example. We're going to pass it a name, and it's going to return an object in which the ID property has that name. That's pretty nice, except this code fails. In ES6, this code is instead going to return undefined, and it's not going to return the new object. So they could have gotten it right. They chose not to get it right, and so you're going to get screwed with this someday, so watch out. So I've been looking at, I've figured out how to make languages better by making them smaller. And I'm still looking at the whole language, trying to figure out how can I remove the imperfections, make it smaller, make it good, make it more perfect, because I want a perfect language. And so I've been reconsidering what I recommended as the good parts. So in the book, I recommended not using new, and I still subscribe to that. New, I think, was a problem. I recommended using object.create instead, which is the fundamental prototypal operator which makes a new object that inherits from an old object. And I managed to get it added to ES5 just so that I could use it. Okay, so I was really happy about that. Thank you. So I was really surprised when I noticed that I've stopped using object.create. And the reason was that I stopped using this. If you're not using this, then there's not much value in using object.create. Turns out that there are a lot of reasons to not use this. One is it makes the language really hard to talk about. Which this are you talking about? This stinks. What stinks? It's like programming. It's pair programming with Abbott and Costello. It's just really. And this has all sorts of really weird properties. Everything is statically bound in JavaScript except for this, which is dynamically bound, and so there are security errors and other kinds of errors which come from the weird behavior of this. a few years ago, there were a number of researchers who were trying to figure out how to turn JavaScript into a safe language. There were a number of projects like FBJS at Facebook, there was the Web Sandbox at Microsoft, there was the Kaha project at Google, my own AdSafe project, and others. And we were all trying to figure out how to make a safe subset so we could have third-party code run with our code without compromising us. And one of the really hard problems in doing that is dealing with this. Because if you have a method, this gets bound to the object of interest and everything's good. But if you call that same method as a function, this is now bound to the global object, which compromises all of your security. And how do you deal with that? And what the other projects did was they had compilers which would rewrite the JavaScript into a much bigger program that had runtime checking and indirection to prevent that from happening. And one of the consequences of that was the transformed program was much slower, and so they had trouble getting adoption. My approach instead was, I can't figure out how to make this safe, so I'm going to make it illegal. So if there's a this in the third-party code, it doesn't get in the system. So that turned out to be really easy. I could do a static validation and determine if we're going to allow the code or not. And my assumption was, or the problem with that is that the percentage of existing code on the web that would pass AdSafe was 0. There's no existing code that will pass because everybody is using this. But my hypothesis was if you remove this from JavaScript, what you have left is still a very nice functional programming language, and that's all you need to do programming. So to determine that that was true, I started writing in that dialect. And I was very surprised to discover that it was not a hardship. It made things easier. I was enjoying programming much more. Things were just working and going together really nicely. So I stopped using this entirely. I stopped using null. One of the problems with JavaScript is it has two bottom values, null and undefined, and they are not the same. They're kind of the same, and some people treat them as though they're interchangeable, but they're not. They have weird characteristics, which causes confusion, and you know where that goes. So I decided, well, I only want to use one of them, and I want to stop using the other one. So which one do you choose? And I decided to go with undefined for two reasons. One, it's the value that the language itself uses. So if you have a missing parameter or an undefined property in an object, that's the value the system uses. So that makes sense. The other is that there's a terrible error in type of related to null. That type of null identifies it as an object, which is wrong, terribly wrong, and that problem is never going to get fixed. So if you never use null, then that error never will affect you, and that's a good thing. So I recommend we should stop using null too. I've also stopped relying on the falsy values. JavaScript's falsy values are the empty string, the number 0, nan, null and undefined. And the reason it does that is to look like C. That C is an undertyped language, and it can do simple 0 checks, which can also look for things like null terminators on strings and null pointers and stuff like that. And JavaScript wanted to provide that same kind of convenience, but the behavior of the null objects is weird and leads to bugs. Sometimes you have a 0 passing into something where you expect it undefined, and it causes programs to get lost. And so I recommend not depending on that anymore. So now if I want to determine if something is undefined, I say triple equal undefined. I don't depend on the falsy check. I don't recommend using for loops. A while ago, I was trying to teach beginners how to do programming, and they really struggled with the for statement because it's got these 3 clauses in it that are separated by commas or semicolons, and there's no identification as to which is which, and they were constantly getting confused. What initializes what's the, because it didn't make any sense to them why it looked like that. And you probably enjoyed that too when you were first learning the for statement, but in the years you've gotten used to it. But it really is weird. And there are errors associated with for, and so I've stopped using it. In ES5, we got these wonderful new methods attached to arrays like for each and map. I use all of those now exclusively. I don't use for statements anymore. I don't use for in. Something we got in ES5 was object.keys, which returns a string or an array of strings. And so with that, you don't need for in. You don't have the problem of that for in has of iterating through the inherited methods, things you usually don't want to be seeing. So it's a much more reliable way to do programming. ES6 will have proper tail calls, as I said before, and at that point I will stop using while. So here are two versions of the repeat function. The repeat function takes a function and calls it over and over again until it returns undefined. The first one is written with a loop. The second one is written with tail recursion. In ES6, these will both run at the same speed. So there's no longer a penalty for using recursion for loop substitution. So when ES6 finally comes out with tail recursion, that's where I'm going. I'm not going to be using loops anymore. So I think a lot about the next language. What's the next language going to be? There's got to be a next language, because if it turns out that JavaScript is the last language, that would be really sad, wouldn't it? I mean, we got to do better for our kids. We got to leave them something better. And how will we recognize the next language when it occurs? It's sort of like waiting for the Messiah. How will we know? What are the signs? And I hear a lot of prophets running around saying, "It's here. It's Dart." No, it's not Dart. It's Python. It was here all along. No, it's not Python. It's something else. But how will we know? And the only thing I'm confident of is that when it finally arrives, we will reject it out of hand completely. And it's because programmers are as emotional and irrational as normal people. Now, we think that's not true. We think because we're the ambassadors to the computer, we are totally logical and rational, and we are not. We're just like everybody else. We're just not aware of how much we are like everybody else. So here's the evidence. It took a generation to agree that high-level languages were a good idea. Back when people were struggling with machine language, Fortran was trying to lift us out of the muck, and the people who were down in the muck said, "Leave us alone, we like it in the muck." It took a long time. It took a generation to agree that GoTo was a bad idea. Dijkstra published his letter in the CACM in '68, and we argued violently, passionately, for 2 decades about whether or not we should do that, whether we should get rid of the GoTo. It took a generation to agree that objects were a good idea. Objects were a good idea. Were best expressed in Smalltalk 80, which is maybe the best designed programming language in history. At one point, the industry had to decide, do we want to go with Smalltalk or do we want to go with C++? And the decision was made by people who did not understand object-oriented programming. And we are still stuck with that legacy. Almost all of our languages since C++ have followed from that genetics and have always gotten it wrong. One of the few exceptions is Ruby, which still went back to the original Smalltalk and gets at least that part of it right. And it took 2 generations to agree that lambdas were a good idea. Lambdas were perfected in the scheme language. It was an important discovery, an important breakthrough, and like all the important discoveries, the industry took absolutely no notice of it. And this one took not 1 generation, but 2 generations before it finally got to the mainstream. Anybody know which language was the first to bring this idea to the mainstream? Anyone? JavaScript. Lisp never got to the mainstream, not within miles of it. So the reason these things take so long is because we don't change minds. I mean, once stuff gets in there wrong, it's really rare that that ever gets fixed. And so it ends up, we wait for a whole generation to retire or die before we can get consensus on the good idea. We imagine, our mythology tells us that someone discovers something and we all move on it, and that's not how it happens. The thing is discovered, and 20 years later, maybe we'll move on to it. So I remember when the go-to thing was happening. There was this loud debate, argument going on all the time. I need the go-to. It's an essential tool. It's how I think. It's how I express myself. I need it. It's so much more efficient. I got all these reasons for why I got to have the go-to. And I understand what you're saying, except I don't understand what you're saying, and I got to have my go-to. And that went on literally for 20 years. And then one day, it was kind of quiet. And we looked around and said, are they gone? Can we get rid of go-to now? Yeah, we got rid of it, and we've never missed it, right? And it's hard in retrospect to understand what were people getting so upset about, because we're doing fine without go-to. All of the predictions about the end of the world and all of that happening when the go-tos go away, never happened. So I'm thinking about the next language, and you can I think you should divide languages into two categories: systems languages and application languages. System languages want to be very low level. It's what you would write kernels and device drivers and memory managers, that kind of stuff, low level stuff. And everything else should be written in application languages. We want to get above the metal, get it to a place, to a greater abstraction where we get more leverage and more safety. And we need new languages in both categories. The dominant systems language today is still C, which comes from the early 70s. We have lost the ability to innovate in systems languages. We're doing more innovation in application languages, but not enough. And some of our languages, I think, get this division wrong. For example, I think the biggest design error in Java was it couldn't decide if it wanted to be a systems language or an application language. And because of its confusion, you end up with things like the requirement to use threads at the application level, which is irresponsible. So in application languages, they're almost all object-oriented today, which is good because objects are good. And they're basically two schools. There's a classical school and the prototypal school. And most of our languages are classical. A few are prototypal, JavaScript being the principal one of those. And it turns out the prototypal school has a lot of advantages compared to the classical school. In classical programming, when you're designing a new system, you have to do a classification. You have to look at all of the objects you're going to have in your system and see how they're related. And then you have to build a taxonomy in which you figure out how all the classes are related, what's going to inherit from what's going to implement what. And that's usually done at the time in the project when you have the least understanding about how the objects are going to work, which means invariably you get it wrong. You just don't have enough information, enough experience to get it right. So you make a taxonomy which is wrong, and that gets built into the hierarchy. And that wrongness finds itself leaking into the new layers as you put them on top. And you also find that you're wishing you had multiple inheritance because things are not composing correctly because you've got these mistakes in the taxonomy. And so you're living with this system which is broken, and that adds a lot of friction, slows you down, and eventually it gets so bad you decide we have to refactor. And that means you go through the whole system and rip the whole thing apart and try to put it together right. But that's really dangerous, and there's a really good chance it's not going to come back together, and it's scary. And that's an inevitable part of classical programming. It doesn't happen when you're working in a prototypal system. And I try to explain this to Java guys. And we tell them, we don't have to do this refactoring. And they go, wow, that's amazing. Except you still have to do the taxonomy, right? And you're still going to be, no, we don't do the taxonomy, you don't do that. And go, wow. But you still do the taxonomy. I mean, they can't imagine that there's any way you can do it without doing all of the stuff that they've ever done. And it turns out you don't. When you eliminate the classical dependencies, a whole lot of work vanishes. You just make an object, and if it turned out well, you make another one that's just like it, and you customize it, and you're done. It's so much easier. So I used to think that the important breakthrough that we got from JavaScript was prototypal inheritance. The major benefit it gives you is memory conservation. The advantage that we have using object.create over object.copy is that we have less memory allocated to each object. That may have made sense in 1995, but it doesn't today. Moore's law has continued to crank on memory capacity. you now have gigabytes of RAM in your pocket. So worrying about how many bytes get allocated to an object is just not worth thinking about anymore. It is a complete waste of time. Unless you're making millions of instances of a class, you don't want to be doing that. And I think if you're making millions of instances, you don't want to be working in JavaScript. I think you want to be working in a better language. But it comes with a cost. So one of the costs is confusion. We now have owned properties and inherited properties, which sometimes act the same and sometimes don't. And that difference can be a confusion. Confusion can lead to bugs, and that's a bad thing. One thing it can provide is retroactive heredity, where you can change what an object inherits after it's been constructed. I've not found a good use for that, and there are lots of obvious, terribly bad uses for that. It is also performance inhibiting, that modern JavaScript engines go very fast by making assumptions about the shape of objects. But when it comes to the prototype chain, they have to be pessimistic because the prototype can change at any time without warning, and so that is slowing down execution. So I used to think that the really important idea we got from JavaScript was prototypal inheritance. I don't think so anymore. I now think JavaScript's gift to humanity was class-free object-oriented programming. I think that is a brilliant idea which is best expressed in JavaScript and was not previously expressed in any other language. So I've got a couple minutes. Let me see if I can demonstrate this idea. So you all remember block scope? We've got the let statement now, which lets you have blocks. Here we've got two blocks. The inner block can see the variables of the outer block, but the outer block cannot see into the inner block. And in JavaScript, we can do the same thing with nested functions. So the outer function cannot see the inner function stuff, but the inner function can see the outer function stuff. And we can express this as a set diagram. Here we've got the set of the variables that the outer function can see. That's the set of variables that the inner function can see. You can see that set encloses the other set. And that's why this idea is called closure, which is a really unfortunate name. I wish we called it something else, because most people think closure means retribution or vengeance. You know, I've been victimized, but I'm going to make some closure. It's going to feel good. You know, oh, yeah. It's not. So anyway, this took a long time to get to the mainstream because the language guys couldn't figure out how to deal with this case. What if the inner function survives the invocation of the outer function? You know, when we call the outer function, we allocate an A on the stack. Then we return the inner function, we pop the A off the stack, but then we call the yellow function, it needs access to the A and it's not there anymore. It turned out it was easy. Stop using stacks, just put it on a heap. If you've got a good garbage collector, it's better anyway. So that's what we do now, and it works. So this is how I'm going to be making objects from now on. I've got a constructor function. I'm going to pass in a specification object. This makes a lot more sense than passing in a bunch of parameters, because your users don't have to remember what order they go in, and you can add new properties in the future and remove old ones that you don't need anymore. It's much more flexible. I'm using the new destructuring syntax to initialize my variables. So I'm going to be creating member variables, which will get initial values from the specification object. So this means the same thing as let member equal spec.member. And I can put as many names as I want inside the curly braces separated by commas, and it will make all of those variables and initialize them from values from the object. I can use the same notation for doing inheritance. So I can call another constructor, and it's going to return an object full of methods, and I can then copy those methods into individual variables. And in fact, I can call as many of these constructors as I want. So I can get multiple inheritance, I can get aspects, it's a very flexible pattern. I'm then going to create my member functions, my methods, and these will close over the member variables, over the other methods, over the methods we're making in the specification object. It does not use this, no this is anywhere. Then the most interesting thing, I'm going to produce an object going out which contains all of the public methods for this object. And we have some new notation in the language where instead of saying method colon method and other colon other, I can simply say method comma other. So if the thing you're outputting is a variable with the same name as the property, you don't have to say the thing twice. And then I'm freezing that whole thing, which makes the object immutable, which makes it impervious to tampering. I worry a lot about security, in particular because I'm working at a company that moves a lot of money through the internet. And so I'm worrying about security all of the time. And making objects which are immutable really, really helps. Also, future JavaScript engines are going to be able to optimize that because there are special properties of immutable objects. Because you know they're never going to change, there are lots of interesting optimizations that are possible. Originally, we had this idea that we have something that looks like a Pascal record, which contains a bunch of properties, and then we associate methods which act upon those properties. So we've got functions and data in the same thing. I think that was an important transition step, but it shouldn't have been the final step. I think instead what I'm doing now is I have an object containing only methods, and it is frozen. And then I've got objects which contain only data, which are hidden behind those methods. And that's a unique pattern that we only find in JavaScript, and I now believe that that is the most effective way to use the language. So I'm afraid I am out of time, so we're going to have to stop here. So thank you, everybody, and good night.